So hello and welcome to this PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Choice and I will be your host. If you're joining us live, please remember that you can ask questions anytime by clicking the chat button in the top left corner of your screen. And make sure that when you do that, you select in the to field there that you select to include attendees, or you might see the word everyone depending on your version of Zoom. And that way all of the audience members will be able to see which questions are being asked by the other classrooms that are joining. If you include your name, your school, or your city, we would love to give you a shout out when we ask your question. So today's guest is Dr. Michael Reid. He is the Public Outreach Coordinator at the Dunlap Institute at the University of Toronto. At this time, I'm going to turn it over to you, and I'm sure you have a lot of pictures to show us and some interesting things to tell us. So thanks for joining us today.
Great. Well, thank you very much for having me. So welcome, everybody, and good morning. As Stacey said, my name is Michael Reid, and I'm a professor of astronomy at the University of Toronto and the coordinator of public outreach for the Dunlap Institute. Now, can you see my slides? There we go. Can everyone see that? Great. Okay, so this morning I'm going to talk to you a little bit about a topic that is very interesting to me and to, I think, a lot of astronomers, and that is the colonization of the solar system. So I'll go through some material with you and show you some great pictures, and then we'll have some opportunity for you to ask questions, and hopefully we'll have a good discussion. So, colonization of the solar system. People like me, when we get into astronomy, one of the things that deeply inspires us to want to learn more about the universe is the prospect that maybe someday some people from Earth will get to go elsewhere in the universe. Now, I want to kind of put this idea into context for you. So let's start with this picture that is hopefully familiar to everybody. This is a very famous picture called the Blue Marble, and probably everyone can recognize that you're looking at our own planet there. Now, some things to note about this picture. If you look at the Earth itself, you know, it probably feels to you very large, right? Many of you may be from places all over the globe, or you may have visited places all over the Earth, and you know that it takes a long time to move around the Earth. If you want to take a trip from Toronto to China or India or Australia, it takes a long time to get that far. And that makes Earth feel very, very big, and it seems like it's almost everything, right? Most of your day-to-day life, you think only about the Earth and about maybe you look up at the sky, but mostly you're looking at the places that are around you and thinking about your life on the Earth. But as astronomers, we spend most of our time looking away from the Earth, looking up into the sky and thinking about all of the places and who knows, maybe the people that might be out there. So I want to kind of flip our perspective here, and instead of thinking about this Earth that we spend so much time thinking about and exploring and interacting with, I want to change our perspective and look outward for a moment. So this is a picture of a galaxy. Now, you may never have looked closely at pictures of galaxies before, so let me kind of explain to you what you're seeing. A galaxy is a collection of many, many, many stars. So this galaxy that you're looking at is a fairly typical kind of galaxy. It's called a spiral galaxy because it has that beautiful kind of spiral shape to it. And it consists of about a few 100 billion stars. So what does that mean? 100 billion, that's 100,000, thousand. It's a really, really big number of stars. And each of those stars is a star like our own sun. The sun is a star. It's a great big hot ball of gas that all the planets orbit. And there are billions and billions of stars like that just in this one other galaxy. Now, if you look very carefully in this image, you'll see that there isn't just one galaxy. Some of the faint specks in the background are also other galaxies. They're a little bit difficult to make out, but they're there. And if we think about the universe as a whole, we find out that there are many, many billions of galaxies. So this one galaxy that I'm showing you is just one galaxy out of thousands and thousands and thousands of them. And as astronomers, when we look out into space and we see all of these galaxies, each of which has millions, billions of stars in it, it's very hard for us not to imagine that, there must be planets orbiting those stars, just the same way there are planets orbiting the sun. And that maybe someday we could go to some of those planets and explore and look around and maybe meet whoever might live there. So that said, we have to make baby steps first. We've yet to really leave the Earth. And so our first question in thinking about, moving out as a species out into the universe is, where could we live other than the Earth? Are there places that would be good for us to live, and that it might be possible for us to live without having to develop too much new technology? We want to think about places where we could live in the near future, not, in very, very far future times. So there are some places, given what we know about the universe already, there are a few places, even in our own solar system, where we could think about sending humans to live for long periods of time. Now, if you know a little bit about our solar system, you may wonder, why would we want to do this? Well, there's always the thrill of discovery, but you may also know, if you look at this picture here, this shows an event that happened on Earth about 65 million years ago, which is a really long time, but that's still well within the time during which Earth had animals walking around on it and things like that. And this shows an event when a huge rock from space hit the Earth, and it wiped out the major species on the planet at the time, which were the dinosaurs, and basically destroyed all of the really big life forms. So if it weren't for this asteroid impact that happened 65 million years ago, Earth would probably be covered with dinosaurs right now instead of with people. And, that's, in a sense, it's tragic for the dinosaurs. It's sort of good for us in that it cleared the way for people like us to come to exist on the Earth. But it's a warning to us that events like this can happen, and that it's a reason we might want to think about having people on other planets as a kind of insurance policy against disasters. There's also, just as I mentioned earlier, the kind of thrill of discovery. So some of you may have seen this wonderful movie called The Martian. This is a still from that movie showing the main character sitting on a rock outcropping on Mars. And this is the kind of thing, more than just the disaster scenario that motivates a lot of astronomers to want to think about leaving the planet. It's just a thrill of going to new places. And if we were very, very lucky, maybe meeting new people. Now, this is a science fiction rendition of what an alien might look like, and we don't know that there are aliens out there. But given all those stars that I showed you and all those planets orbiting all those stars, we like to hope that maybe someday we will meet some aliens who may or may not look like this one. So where could we go? What kind of planets could we go and live on, even in our own solar system, as a first step off the Earth? Well, let's look at the solar system. So probably you have seen images like this before that show all the planets in the solar system. And you may know that we have the sun on the left side of this image is the big glowy ball. And then we have 4 small rocky planets: Mercury, Venus, our own Earth, and Mars. Those are all small planets made mostly of rock. Then we have 4 gas planets: Jupiter, Saturn, Uranus, and Neptune. Now, those gas planets are not places where we could go and live because they're mainly made of gas and liquid. There isn't a solid surface we could sit on and walk around on. So they aren't good places for us to go and try and live. But the rocky planets might be. Now, let's look at the rocky planets. So we'll start with Mercury. If you look at this picture of Mercury, you can see right away it looks an awful lot like our own moon. And if you know much about the moon, if you've ever looked at pictures of astronauts wandering around on the moon, you know that it's not the greatest place to live. Places like the moon and Mercury are basically barren rock with no air to breathe and really extreme temperatures. So on the moon, it's very, very, very cold. And on Mercury, it's very, very, very hot because it's so close to the sun. So not great places to live. How about the next planet? This is the planet Venus. And when you look at this picture, you may notice that it's very different from the picture of Mercury. In the picture of Mercury, what you're seeing is the surface of Mercury. It has no clouds, no air, no atmosphere. So what you're seeing is the barren rock on the surface. But in this picture of Venus, you're seeing just the opposite. Venus has a very thick atmosphere, so thick that you can't see the surface at all. And all you're seeing in this picture are the cloud tops on Venus. And in fact, this atmosphere is one reason why Venus would be a very bad place for us to try and go and live. It's a very, very thick atmosphere, so thick that if you were to stand on the surface of Venus, you would feel the atmosphere squishing you and squeezing you. It's also incredibly hot on Venus because of this thick atmosphere. It holds a lot of heat. And that means that it's way too hot for humans to survive there. If I kind of compare Earth and Venus, you can see that they're sort of vaguely similar looking. You know, Venus has a lot more clouds, but they're both about the same size. They have a lot of features in common from the outside. But if you look at this picture from the surface of Venus, you'll see that they don't look very similar. So this is one of the very few pictures we've taken from the surface of Venus, and you can see that it is truly, truly a barren wasteland, not much going on, just sort of rock all over the surface and a very toxic looking sky, which is in fact a toxic sky, not something that you or I could breathe. And of course, it's very hot. So we couldn't live on Venus, or at least not in the foreseeable future. But how about this planet? So some of you may know this one. The planet on the left, of course, is Earth, but the one on the right is our kind of a little baby cousin, and that's the planet Mars. Mars is a lot smaller than the Earth, so at first glance it may look like, well, you know, maybe that's not such a good place. It's a bit small, the gravity is low. But there are a lot of things about Mars that actually make it very similar to the Earth and a good place for us to think about living. So if you look at the surface of Mars, this is a picture taken by a robot on the surface of Mars, you can see that, you know, it's not totally unlike Venus. It does have mostly just rock on the surface, but it's not as hostile looking as Venus either. There isn't this crushing, thick atmosphere that Venus has. In fact, Mars has very little atmosphere, which is in some ways a bad thing. It means that there's no air for us to breathe on Mars, but it's a good thing in the sense that there isn't a crushing toxic atmosphere the way there is on Venus. So as long as you have air and a source of heat on Mars, because it's very cold there, it's actually not a terribly difficult place to imagine living. Okay, you can see that if any of you have ever been to some place like Arizona or New Mexico or a desert anywhere on Earth, it doesn't look too different from this picture of Mars. Another nice thing about Mars that makes it a good place for us to think about going and living is what you see in the bottom of this picture. So this is the whole globe of Mars, and at the bottom there you see an ice cap. And that ice cap is a source of water. Some of that ice cap is made of water. And that means that it's a good place for us to think about going, maybe living near that ice cap and being able to melt some of that ice to extract water and other valuable chemicals that we can use to support life. Like us. Now, a long time ago, we know that Mars was covered in liquid water in more or less the same way that Earth is now. That water is all gone. It's either boiled away into space or it's frozen into the surface. But as pictures like this one of an old riverbed on Mars show, so this picture that you're seeing shows a place where water used to flow a long time ago. These show us that Mars used to have water all over the place. And in fact, although this is what Mars looks like today, you know, it's mostly kind of rock and a very, very thin, wispy clouds. Billions of years ago, Mars would have looked like this, much more like Earth. It would have had oceans and seas and rivers and lakes, and we're not sure, but it might have had life. Now, we don't know about that, but that's one of the reasons that we're so eager to go to Mars, to try and check and see with our own hands in the soil, is there any life that still survives on Mars? Did life ever evolve there? Does it survive to the present day? Now, can we get there? Can we actually go to Mars? Well, this is a difficult question to answer. The easiest way to answer it is to say, you know, yes, absolutely we can get to Mars. There's no reason we can't send people to Mars. We send robots to Mars all the time. So there's no reason we can't send people to Mars. However, there are some challenges in doing that will, determine whether or not that happens sooner or later. So you may have heard of this company called SpaceX, run by a famous guy called Elon Musk. And he has this plan to send spaceships to Mars within the next 10 years and land people on the planet and build a kind of a colony like what you see here in this picture. And people have been planning that kind of thing for a very long time. People have been, making plans like this for a very, very long period of time, decades, since long before I was born, but no one has done it yet. And part of the reason that no one has done it yet is that it's very, very expensive to imagine going to Mars. It would cost many, many billions of dollars. And for people to do that, for this to happen, one of two things has to happen. Either the governments of the world need to decide that moving some of the human species to Mars is a priority, and they have to decide to spend that money, a large amount of money, to do it. Or we have to develop our technologies to the point where it's cheaper for us to go to Mars. And that's what people are working on very hard right now, trying to make it less expensive for us to build ships and habitats on Mars. There's a problem, though, with Mars. Mars has almost no atmosphere. And as I mentioned earlier, that can be good in the sense that, well, at least it doesn't have a bad atmosphere. But the fact that it has very little atmosphere means that there's not much on Mars to protect us from dangerous radiation from space, which means that if we go to live on Mars, we'll have to figure out some way of protecting ourselves from dangerous kinds of radiation that will otherwise hit us from space. So there are many different ways people have imagined to do this. One is to just live underground. And you can see in this artist rendition here, this idea that people will live in habitats that are buried underground and only occasionally go up to the surface. And that's one way we might do this. But there's another way to think about this problem. So Mars is a good place to live. It has a lot of advantages, some water still on the surface there, maybe life that may exist that we could find. It's got a lot of nice features. But there's one other place in the solar system we could think about living. Now, it's much further away, and that makes it harder to get to, so it wouldn't be someplace that we would go very soon, but it has a lot of advantages. So you may recognize that what you're seeing here is the planet Saturn. That big thing in the background is Saturn, and then that line that cuts through the middle is Saturn's rings, seen edge on. But the ball in the foreground, the kind of darker one, that's a moon of Saturn. And that moon of Saturn is called Titan. And Titan is a place that people are very excited about maybe one day living, because it solves a lot of the problems that we would have with living on Mars. So here is a picture of Titan. You can see it's a bit of a funny picture. We haven't sent spacecraft to Titan nearly as often as we have to Mars, so our pictures aren't quite as nice. But what's very interesting about Titan is that unlike Mars, where we said it used to have oceans, Titan still has oceans, even today. Now, the downside of this is that they're not oceans of water, which would be great. If they were oceans of water, we would, plan to go today. But they're not oceans of water. They're oceans of something called ethane and methane. And those are similar to natural gas, the thing that you may use to kind of heat your homes and power your natural gas fireplace, things like that, run your barbecue. And that's not great because humans can't really survive in oceans of natural gas. But it is good in the sense that it gives us loads and loads of basically free energy if we go to Titan. You could basically just take the liquid out of the oceans and use it as an energy source directly. So it's very, very convenient. But another really nice thing about Titan is that, as you can kind of see in this picture a little bit, it has a thick atmosphere, a bit like Venus. In this picture, you can actually see on the top of Titan there some sunlight glinting off those oceans. But that thick atmosphere makes Titan really useful in that it has this built-in shield to protect us from dangerous radiation from space, something that Mars doesn't have. But actually, because Titan is a fairly small moon, that means it has low gravity. So if you think about, watching videos of astronauts on the moon, in low gravity, it's easier to jump and bounce around. That would be the same on Titan. But unlike the moon, which has no atmosphere at all, Titan has quite a good atmosphere, a thick atmosphere. And that means that the combination of low gravity plus a thick atmosphere means that it would actually be possible, if we moved to Titan, for you to fly on Titan just by flapping wings. So you could strap wings on and you could fly around on the surface of Titan. It's a very fun place to think about someday living. Lots of resources that would be useful for us. Nice, protective, thick atmosphere to keep us safe. And so it's a place that many people are thinking about going maybe a little bit further in the future than Mars. So as I mentioned, just a little picture here to show you what the surface of Titan is like, covered in these oceans. This is a top-down picture of the oceans on Titan, just to prove to you that they really do exist. So that big black smudge is the surface of one of the oceans on Titan, and then you see the land all around it is the white stuff. So you could imagine maybe going there and living on the shore of one of those oceans. So my question for you before we take questions is, are you ready to go? I think that the first people who go to places like Mars and Titan will be people like you, people who are currently students who may someday go on to become astronauts and be among the first people to leave Earth. And I hope that that is what gets to happen for some of you. So I will stop there and take any questions that you may have. Thank you very much.
Thank you so much. I think the rest of my day is going to be spent picturing myself with some wings flying over that lake there. That's pretty neat. I hadn't heard that before. We do already have a few questions. I'll just remind you there, if you could quickly click that red button to stop sharing, then we'll be able to see you a little better. Excellent. Our first question comes from Norman Ingram Public School in Toronto. And they were wondering how the gravity of Mars compares to the gravity of Earth.
Yeah, so the gravity of Mars is quite a bit lower than the gravity of Earth. I think it's somewhere around a quarter of the gravity of Earth. And, again, that's it's reasonably good in that, it still holds you to the ground, but you get that nice light feeling and you can be a little bit bouncy in your step. One thing we're not sure about, though, is it good for humans to spend a long period of time in low gravity like that? And that's one thing that people are researching using astronauts on the International Space Station, where they don't really feel gravity at all, trying to figure out, is it okay for humans to live for long periods of time in low gravity? Right.
And we also have a quick note from that class at Norman Ingram that they have 4 volunteers already that will go.
Amazing.
So next, we have a question from Ripley, Ontario. Ms. Adams' class wondering, how much atmospheric pressure does Earth have?
How much atmospheric pressure does Earth have? That's a funny question. It has, the way we usually measure atmospheres is we measure them relative to Earth. So we say that Earth has one atmosphere of pressure. That's our unit for measuring that. So it's a slightly unsatisfying answer, but we say it has 1 atmospheric pressure. If I compare that to another planet, for example, Venus has something like 90 atmospheric pressures, so 90 times the atmospheric pressure of the Earth, which is similar to what you would feel about a kilometer deep in the ocean on Earth. So very, very crushing pressure compared to the Earth.
Excellent. Next up, we have a question from Dunlap Public School, wondering if Ceres is habitable.
So Ceres, some of you may not have heard of Ceres. Ceres is a dwarf planet, and it's a little thing kind of about the size of the moon that orbits in between Mars and Jupiter in kind of what we call the asteroid belt. And it's small, as I say, it's about the size of the moon. And in many ways, it's similar to the moon in that it has no atmosphere. But unlike the moon, which is made mainly of rock, Ceres is a mix of rock and ice. So it's not an easy place to live in that there's no air to breathe and it's a bit far from the sun, so the light would be a little dim. But it does have water, for sure, that we could melt and use, and some of that water could be separated into oxygen to breathe. So it's a place you could imagine living, but it would be a little bit trickier than Mars or Titan.
It seems like everywhere we found so far, there's at least something tricky about it.
Yeah, that's true. There's no planet we know of yet that is just like Earth, ready for us to move in.
We'll keep looking, I guess. But then the trick will be that it will be very, very far away.
That's right. Yeah.
Now we have a question from Ms. Kantartzis' class. Was there once water on the moon?
Was there once water on the moon? There definitely was, and in fact, there still is. So we have to be careful when we say, is there water in a place? Because usually when we say that, we imagine liquid water flowing freely like it does on the surface of the Earth. There is no liquid water flowing freely on the moon. It's far, far too cold for that. But there is frozen water in the surface of the moon. So in the soil of the moon, there is still some water frozen in there. And that's, if we decided we wanted to live on the moon, we could actually start heating up the soil and melting some of that water out so that we could use it for drinking water and things like that. But there isn't a lot of it, which makes it a bit more difficult than someplace like Mars, where there's lots of it frozen into the soil, or Titan, where actually the ground is made of frozen water. There isn't much rock on Titan. The ground is just water ice, mostly.
Interesting. So we have a couple of related questions I'm going to toss your way now. One from our kids at Hillcrest Public School in Campbellford. They're wondering how stars are formed into galaxies. And we have another class that was wondering why the picture of the galaxy that you showed us had a brown spot in the middle. So how do stars form galaxies, and why is there a brown spot in the middle?
Yeah, those are related questions. So stars are formed from big balls of gas in space. So out in the space between the stars, there's lots of gas out there floating around, and over time, the spinning of the galaxies and different events that happen in galaxies can sweep that gas up. And if enough of it gets brought together, it will start to squeeze itself the rest of the way until it turns into a star. Now, you may have noticed, as some of you did, that although the center of that galaxy was sort of yellowish brownish, the outside was very blue, okay? And that's because very bright young baby stars are bright blue, okay? And there are loads of those in the outer areas of galaxies. But in the centers of most galaxies, the stars there are older. There's a lot of gas there. The stars mostly formed a long time ago. They have aged a lot, and all the baby blue stars are basically gone. So all you're left with is the older stars, which tend to be yellow or red. And so that's why in the centers of galaxies you see yellowish, reddish light. And then out on the outside, where many new stars are being formed, you still see a lot of blue light.
Wonderful. Next, I have a question from Mr. Stark's class at Beatrice Strong in Port Hope. We have one student who would like to ask, could we colonize an asteroid?
Could we colonize an asteroid? That's an excellent question. So a lot of people are suggesting that that is exactly what we should do instead of colonizing planets. So there's a very tricky thing with colonizing planets, and that is that planets have gravity. And even if it's not very much gravity, it's still, not something you can't ignore. So if you imagine going to Mars and you land a spaceship on Mars, if you want to leave again, you need fuel to do that. And it would be terribly, terribly expensive to send all that fuel directly from Earth, way too expensive. So the only way to do it would be to make that fuel on Mars. But that's tricky. You wouldn't necessarily want to leave for your trip to Mars knowing that the fuel to get you home hadn't been made yet, and you were going to have to make it when you got to Mars. That would be a bit scary. But asteroids kind of solve that problem in that they have very little gravity at all. So you can land on an asteroid and then leave again using very, very little fuel. And you don't have to necessarily worry about this difficulty of needing to make the fuel for your trip home when you get there. So a lot of people suggest that asteroids are an easier place for us to go first instead of to a planet. The downside of asteroids, of course, is they have no atmosphere. They have very, very little gravity. So if there are bad health effects associated with low gravity, then you would have to deal with those on asteroids. But it's still something people are exploring actively.
Excellent. Next, we have a question from the grade 3s at Bellwood, wondering if you could explain how Oh, I guess, sorry, I queued this up a minute ago and you just answered how we would get back to Earth from Mars. So they were asking that before, wondering. So thank you for answering that question from the grade 3s at Bellwood. I will then go to the next question I have queued up here from our students at North Agincourt. And Carl wondering, how long would it take us to reach Titan? And we had this question from Mr. Stark's class as well.
How long would it take us to reach? So the answer to every question about how long would it take us to reach anywhere in space is how much money do you want to spend? It's kind of like, you know, if you want to go to Australia, how long will it take? Well, if you want to go the really inexpensive way, you're going to build a canoe and you're going to go to the ocean and you're going to paddle your canoe to Australia, and it's going to take you years to get there, if you get there at all, right? Or if you have a lot of money, you know, you can hire the space shuttle and they'll fly you there in an hour and a half. But you need a lot of money to do that. And it's very similar for space travel. If you want to go the cheap way to Titan, it will take a very long time. It could take decades to get there. But if you want to spend a bit more money and get a fancier rocket and a little bit more fuel, you could probably do it in something more like, you know, 5 or 6 years, something like that.
Well, I just came across a very interesting question from Ms. McClinton's class, wondering would we be able to dump our waste on other planets?
Yeah, so this is another question that astronomers think a lot about. So you may like to know that there's a very interesting job at NASA some of you could apply for someday. It's called the Planetary Protection Officer. And the job of the Planetary Protection Officer is to try and make sure that, first of all, that if there is life elsewhere in the universe, we don't accidentally bring it to Earth without knowing we have done that, because what if it's dangerous? But also to make sure that when we go to explore other planets, even with the robots that we're already sending all the time, we don't accidentally take Earth life with us to other planets. Because imagine this, imagine we go to Mars and humans live there, and we don't know yet whether there's life on Mars until we already send humans, and those humans dump their waste products on the surface of Mars, and those waste products have all sorts of Earth life in them, bacteria and viruses and things like that. What if those Earth life forms do bad things to the Martian life forms? What if we go to Mars and discover that all the life we brought with us kills all of the life on Mars? We don't want that to happen. So this is one of the reasons actually why going to Mars will be tricky, because we want to be sure that any things we bring with us, any organisms, plants or bacteria, things like that, that come with us from Earth don't harm Mars. So probably we would initially try and you know, incinerate all of our garbage, burn it up so that it doesn't let live organisms go on the surface of Mars. But this is a big problem.
And we have a question now for you. Are you willing to go to space? The students in Miss McClinton's class are wondering.
Yeah, I would love to go to space. So right now, if you want to become an astronaut, unfortunately, I'm not allowed. I'm too tall. They have very, very restricted requirements for becoming an astronaut. You have to be a certain size because the seats on all the spaceships are only a certain size, and I'm too big. But many of you, by the time you guys are a little bit older and ready to think about this, we will have a whole new kind of spaceship, many new kinds probably, and it will be possible for many of you to go to space if you choose. In fact, it may even be something that you can just buy a ticket the way you would on an airplane and go into Earth orbit or to the moon or maybe even to Mars.
Very interesting to think that that might be a vacation option for our students someday. Mm-hmm. We are already a little bit over our scheduled time. We have many more questions here, and we're happy to take a few more. If you do have to run, then please rest assured you will not be interrupting our broadcast by doing so. We're so glad everyone has joined us today, and if you can continue to stay, we can go for about another 5 minutes or so, I think, here. So next we have several questions coming in about the radiation you mentioned in space. And the possibility of building some type of protective atmosphere, whether that is sort of a magnetic atmosphere or some type of chemical atmosphere Can you maybe give our students a bit of an idea of what that radiation is and whether we could build something on Mars to protect us?
Yeah, so there are at least two kinds of radiation we have to think about. And Earth has natural built-in shields for both of them. So one kind is dangerous kinds of light from the sun. You probably know that if you go out in the summer and you don't wear sunscreen, you can get a sunburn. And if you continue to get sunburns over a long period of time, it can harm your health, and it's not good for you. On planets like Mars, there is no built-in screen against those kinds of harmful rays from the sun. So on Earth, when you're putting on sunscreen, you're just protecting against a little bit of those kinds of light that get through the atmosphere, but the atmosphere blocks most of them out. On Mars, there's not enough atmosphere to block almost any of them out, so the astronauts on Mars would be exposed to those dangerous kinds of light from the sun all the time. The other kind of radiation you have to worry about is what are called cosmic rays. These are particles in space, little tiny atoms that are zipping through space very, very quickly. And if they hit you, they can damage your DNA and make it, they can make you sick or make it difficult for you to have children, things like that. And on Earth, Earth has a huge magnetic field that protects us. It deflects a lot of those cosmic rays and prevents them from getting to the ground, which is great. But Mars does not have a magnetic field like that, and so those particles would all reach the ground, which would be bad. So how do you defend against those? It's actually really tricky. You can't just do something like build a dome, because a dome isn't, you can't build a thick enough dome very easily to protect you against all these particles. So you would have to do things like live underground, under, you know, a meter of rock, or a meter of water, or whatever else you can put over your head. Or, as some of you have suggested, you could use an atmosphere. You could try and add atmosphere to Mars. You could do something like melt the ice caps and have all that gas trapped in the ice caps become a new atmosphere for Mars, and that would help block some of these cosmic rays. But that would be a huge project, a bigger project than humans have ever tried before, and difficult and expensive. So for the first little while that we were to live on Mars, we would have to do things like live underground or live in protective shelters that would shield us from some of these radiations.
Excellent. So I have, I think, two more questions here, and then we'll have to wrap it up and let everyone get on with their day. But first, I have a question from Ms. Hornet's class, wondering what would you need in space to survive, and are we at that point? Zoe at Ottawa Crescent is asking.
What would we need in space to survive? This is a very important question. So, I mean, we would need all the same things that you need here on Earth, right? You need air to breathe, you need water to drink, you need food to eat, you need some source of energy to keep you warm and power whatever devices you have to bring with you. And luckily, you know, most of those things are available in some form on most of the places we might like to visit. So Mars has water. It has energy you can gather from sunlight. It doesn't have food, and it doesn't have air that's already there. You can make air from the ground on Mars, from the chemicals in the soil, but there's no food. So food is a big stumbling block for thinking about living on Mars. We'd have to try and bring our own food or grow our own food or something like that, because there isn't any to eat there. So that's a big issue on Mars. And people are working on these kinds of things, again, using experiments on the International Space Station, trying to figure out how much of our food and water and things can we continually recycle without having to resupply from Earth. And that's something people are working on a lot right now.
Excellent. Well, our very last question on the day today is from our students at Hillcrest Public School in Campbellford. And they're wondering about your education and career path. So if we have any students out there who are interested in studying these things and doing what you do, or the things that you've described, what would they need to continue pursuing in their studies, etc.?
Yeah, so I'll give you kind of two answers to that. So I'm an astronomer, not an astronaut, although I don't get to go into space, unfortunately, but I get to study space from Earth. And if you want to become an astronomer, then what you do is, you know, you keep studying your science and your math and all of those things. In high school, You take science classes, right? If you're given the choice, make sure that you take as many science and math classes as you can. And then in university, there's different things you can do. What I did was I studied physics, which is something that you'll get to in high school. And at some universities, you can just study astronomy right away. But at most schools, you start off studying physics, and then you do that for your first degree, and then you have to do another degree after that, where you get a degree in astronomy, and that's what makes you eligible to become a professor. That takes a long time, but it can be a lot of fun. If you want to be an astronaut, your options are a little bit wider. Astronauts can be all sorts of different kinds of people. They can be scientists like me, but often they can be engineers. They can be medical doctors. They can be pilots or people in the military. And sometimes they're all of those things. Astronauts are usually very, very smart, very, very talented, highly skilled people. So they may be engineers and doctors, or pilots and engineers, things like that. So if you want to be an astronaut, the thing is to make sure you get lots of training, stay in good shape, and keep your eye on space.
Well, that is all the time we have. Thank you so much, Dr. Reid, for taking the time to show us such wonderful pictures, tell us such neat things about the planets you showed us, and to answer our questions today.
You're very welcome. Thank you.
So just to let everyone know, we have a few upcoming PIR live event webinars on bendable electronics, Canadian history, and coding coming up soon. So please do go to pirweb.org if you'd like any information about those or other educational programs. Thank you for tuning in, everyone, and have a wonderful day.